Hey, this is going to serve as a kind of a homework and quiz help. Not really an example, but it's just an explanation of uh, what you might, where you might have problems on the homework and the quiz, and it has to do with ramps and angles. And what we're doing here is we're looking at the vectors that make up uh, a a block on a frictionless inclined plane. In fact, that's the name of the file block on a frictionless inclined plane. It's not mine. I didn't write this mathematics script. This was written by Fernand Brunschwig and Joe Bolte. The So what we're seeing here, this is the gravitational force. Force equals mg, so it's the mass times gravitational acceleration. In this example, we're using 10 meters per second squared for the gravitational acceleration. I know it's 9.8 meters per second squared, but this kind of makes it a little easier, makes the numbers come out a little bit better. And you're only introducing a 2% error if you use 10 meters per second squared as opposed to 9.8 meters per second squared. So we see a force here, the gravitational force, and the force that is perpendicular to the plane is mg cosine theta, and the component of force that's parallel to the plane is mg sine theta. So the acceleration is what gets modified. The mass is going to be the same for this for the entire time, but what does change is the acceleration. We have normally g, but perpendicular to the plane you have g cosine theta, and parallel to the plane you have g sine theta. And you can see that the right now the angle is 30 degrees, so the acceleration is reduced to 5 meters per second squared. If we were to release a block, it would um, slide at a particular rate. If we take the angle way down, let's just make it something like, oh, see if I can get to 5 degrees. Oh, there's 6. That's good enough. And if you can see that the acceleration is very, very slow because there's not the component of acceleration parallel to the plane is very, very small. Now let's make it, let's take it up to like 85 degrees and drop it. You can see it's very rapid. So the acceleration is dependent on the angle. The normal force, the component of acceleration that's perpendicular to the plane decreases as we increase the angle. You can see the normal force is getting smaller and smaller. Basically, it goes down to nothing when we're perpendicular. So as I increase the angle, the normal force decreases. As I now watch for the acceleration on vector parallel to the plane, we can see as I increase the angle, it increases. And those are related to questions that you're going to see on the quiz and the homework. So hope this helps. As the angle increases, the acceleration, the component of acceleration parallel to the ramp increases. Okay.